All right, so my name is Angela Fuller, and I'm one of the associate directors of the CompSysNet, and also an associate professor in the Department of Natural Resources here at Cornell University. Also the leader of the USGS New York Cooperative Fish and Wildlife Research Unit here at Cornell. And I welcome you to the last presentation of this fall's Computational Sustainability Virtual Seminar Series. And we're happy to offer this opportunity to those of you who are interested in computing and sustainability from across the globe. We plan to have more seminars this coming spring, and you'll be able to find that schedule once it's finalized, as well as all of the recordings from previous seminars on the CompSysNet website under the Videos and Events tab. This virtual seminar series is organized by CompSysNet with support from the National Science Foundation and also Cornell University. A little bit of logistics. During the webinar, you can ask clarification questions using the chat button or the chat window, which is on Zoom. And so if you'd like, you could find that chat window now and write hello to everyone, including or mentioning your location. So try that out now. We'd also like to have an active discussion after the presentation, so please post your questions to the chat window, and we'll be sure that they're addressed after the talk. I'd like to also draw your attention to different social media options that we have available to you here at CompSysNet. One is a Facebook page, another is Twitter, and also we have a computational sustainability blog. And so please share our invitation to connect with colleagues who might be interested, and you can also like us on Facebook on the CompSysNet Facebook page to keep track of both news and upcoming events. And so now I'm very happy to welcome Professor Nicole Sintov, who is an associate professor or assistant professor of behavior, decision-making, and sustainability in the School of Environment and Natural Resources at Ohio State University. Her PhD in psychology is from the University of Southern California, where she worked with Professor Milind Tambe and became involved with computational sustainability there. And as an environmental psychologist, her work focuses on designing and evaluating interventions that are aimed at encouraging pro-environmental behavior. She also investigates psychosocial processes of change that occur during behavioral interventions to uncover not only which behaviors changed, but also how and why such changes occur. Her work spans a number of different domain areas, including building energy use, sustainable technology adoption, and the food, energy, water nexus. So Nicole, thank you so much. It's wonderful having you here, and I'll now turn it over to you.
Thank you, Angela, and thank you everyone for joining. I want to apologize up front that I'm recovering from the flu, so I may be coughing a little bit during the talk. So again, thanks Angela for the nice introduction. I'm going to be talking today about how to concurrently advance theory as well as make practical impacts as part of programs to promote sustainable behavior in real-world settings. And I want to start by telling a story. Recently, I was having lunch with somebody who works with the Ohio State government. He was telling me about a new chandelier that he bought for his house. And he was really excited because the chandelier took LED bulbs and he wanted to put them in, and he was trying to convince his spouse to do it, and she was not about it because of the visual aesthetic. He was like really, really frustrated that he could not convince his spouse to put these LED bulbs in. He's like, what can you do, Nicole? Like, you're the psychologist. Can you help me figure this out? And this has become such a common type of conversation for me that it's almost like a Mad Libs. Whenever I tell someone what I do, they're like, oh, great. I'm so glad I met you. Maybe you can help me because there's this person in my household that's always doing this unsustainable thing. And I really want them to do this more sustainable behavior. So what should I do? And they're always focused on how they can change someone else and not necessarily themselves. But this is a good starting place because people are recognizing that changing individual behavior is part of the solution for a sustainable future. And if it's the case that we are trying to change our behavior, well, can't we just change ourselves? Decades of behavioral research has shown that we can be successful in intervening in human behavior. Everything from encouraging people to exercise more to getting people to use less energy in household settings. But it's often not that easy. And as anyone who's ever tried to lose weight or change their eating habits can attest to, you know the value of resisting those donuts, like this guy here. But when they're sitting there staring you down, the desire to devour them can be overpowering. And so even though your heart can be in the right place and you can be motivated, changing your own behavior can be quite challenging. So think about how challenging it can be to try to change somebody else's behavior when they're not even potentially motivated to do so. And amongst social scientists, there's kind of two main camps of people working at this juncture to figure out how people make these choices and their behavior. So there's the decision scientists who come up with great mental models of how do people make decisions that impact environmental resource use, what factors do they consider, what happens when you highlight different factors. And then there are the interventionists, and these folks tend to come up with tools and evaluate the efficacy of these tools in actually changing behavior. The issue is that these camps don't intersect too much, and that's a bridge that my work tries to build. And so in my work, our approach to studying behavior change focuses on why interventions work. So if we're looking in this black box of human behavior, we want to uncover things like how decision-making and behavior change throughout the course of an intervention, how long changes persist, and which particular behaviors change, because all of this can inform intervention design for rollout and scaling in the real world. And we ask these questions as they apply to a whole host of different outcomes. Angela touched on some of these. And I'm going to focus on a couple projects today, just to give you some more concrete ideas of the type of work we do. One study is on home energy use, and another is on waste management. A couple other notes about the work in my group. We take a very interdisciplinary approach. A lot of our work is with engineers and computer scientists. That's how I got involved in CompSysNet. And also, a lot of our work, the vast majority, is done in the field in conjunction with field partners. And by field partner, I mean anybody outside of academia who is doing work on the ground. So this could be NGOs, it could be people in industry, it could be people in government, etc. So why would we work in the fields when we could, as psychologists especially, have a nice tightly controlled study in a lab? Working in the field is messy. Well, it turns out there's a lot of benefits to collaborating with field partners. So first of all, government funding agencies are increasingly requiring or encouraging field partners as part of funding proposals. So for instance, NSF's Partnerships for Innovations program requires field partners, and the European Union's Horizon 2020 evaluates proposals more favorably if you have field partners. Field partners can also fund your research, especially industry, when government funding wanes. As well, field partners can give you access to different populations or technologies that enable you to answer research questions you otherwise would not have been able to. And having kind of this intimate knowledge of what's happening on the ground in the field can also help you better understand your problem context and lead to the development of new research questions. There's also some evidence suggesting that, when we do our work in the field, we have improved research impact, depending on how that's measured. And then there have been studies showing that academics who collaborate with field partners have superior performance in terms of things like publications and funding relative to academics who do not collaborate with people in the field. So there are lots of benefits to these sorts of collaborations. If that's the case, why don't we collaborate more often? It turns out that we have pretty different agendas, and I'm going to go through how we can think about these as they fall across the lifetime of the project. And I'm going to be talking from a social scientist perspective because I'm a social scientist, but a lot of the points I'm making can apply to a broader audience. So if we think about setting the objectives for a project, academics really want to advance knowledge broadly. That's kind of our goal. And on the other hand, practitioners are often interested in narrower practical implications of a research project. So what does this mean for my profits, for my products, for my shareholders? How can I implement these solutions to my own internal operations? When it comes to designing and executing a project, academics, especially social scientists, are often very interested in control because we want to make very nice, clean theoretical conclusions. Practitioners, on the other hand, are not so keen on control necessarily, but they're very good project managers, very timeline focused, focused on deliverables and getting the project executed. But those are very different approaches to how you get the work done. Then when it comes to sharing results, academics tend towards broader dissemination of findings to many audiences, and we tend to qualify our results as well to talk about the caveats and the limitations. On the other hand, practitioners tend towards a little bit narrower dissemination, especially if the results may not be favorable. And they can also tend towards a little bit more generous interpretations of data than academics might be accustomed to. This all kind of boils down to academics being incentivized to advance theory, and this feeds into systems of promotion and tenure. And practitioners are often more interested in practical solutions that can be implemented in their own organizations. They're very different agendas. And that leads to the question of, can we even work together successfully when we have such different agendas? Well, let's think of some other examples when our agenda might differ from somebody else. So let's say you want to go on vacation and you want to go with your spouse, and you are very excited to get out of the Northeast, for instance, Ohio, where it's really cold right now. So you want to go to Hawaii, and your spouse is dead set on Iceland. So that's not very similar. Do you scrap your trip? Hopefully not. Hopefully you discuss it and you hear from each other what you're each looking for. And maybe through a process of communication, you get on the table some of the things that you want out of the trip. So let's say you both want to spend time with one another, you both want to spend that time outside hiking, and you both want to try new food. So through this process of sharing and communicating, we can get on the same page. A collaboration is no different. It is a social relationship whereby a project proceeds with successes achieved and failures made in the context of this relationship. And although there's been quite a bit of prior work on what can make a successful or unsuccessful collaboration, the fact that there is this social underpinning has been largely overlooked. And that's what I'll focus on for the rest of the talk. So I'm going to go through a couple specific projects where we had successful collaborations with field partners. And the first project is on residential energy conservation, and I'll talk about how we made some theoretical advancements as well as some practical impacts that satisfied our field partners. And then I'll talk about a study on household waste management where we contributed to the literature on behavioral spillover. I'll talk about what that is later. And on the practical side, we helped a city with its municipal waste operations. Okay, so the first project, the energy one, let's back up a little bit and talk about the motivation for this project, and it's that electricity consumption stems from and is maintained by human choices and behavior. So particularly in the US, the residential sector is responsible for the largest share of electricity consumption. And if we look at what people are doing in their homes with electricity, it's a whole lot of things. But I guess the point here is that if we're trying to shrink this pie and if we're trying to shrink the residential sector, we need to know which of these activities that we want to target. So it goes back to that notion of what behaviors can we change. And this is one of the questions that we were exploring back when I was at USC as part of the Los Angeles Smart Grid project. And this was a very large project. It was 5 years, $120 million, funded by Department of Energy. And it was a citywide collaboration between the Los Angeles Department of Water and Power, USC, the other school across town, UCLA, and the NASA Jet Propulsion Laboratory. And I was the lead on the customer behavior portion of this project. And one of our projects involved instrumenting an on-campus residential apartment building called Floor Tower. There's a picture of it. This building had 40 suites in which students lived. They were all freshmen. And all suites had identical layouts in terms of number of rooms and orientation of those rooms and equipment. And we, excuse me, outfitted each of those suites with a smart electric meter. So this is an electric meter that measures power consumption every 15 minutes in this case. On the other hand, all the other buildings on campus have one electric meter for the entire building, and a lot of them are analog meters, so they're not digitally gathering data and able to send that data back in near real time like these smart meters are. And so here's a schematic of our system. We have our test building with each of the 40 suites submetered. That data got sent to our facilities management system, services, who did quality control checks on it. The data then got sent to Lucid, which is a third-party software development company that processes and visualizes the data. And then that processed data got sent back to the building to a touchscreen kiosk in the building lobby where students could interact with their energy data. And we leveraged this system as part of a competition for the students to conserve energy in the building. So the suites were competing against one another to conserve. And here, to give you a little bit more of a concrete idea of what this looks like, this is a picture of the kiosk in the lobby. And here's a screenshot of the kiosk. Each of these bars represents the amount of energy being used by an individual suite when the screenshot was taken. You'll notice that the suites have names of games on them, and there's two reasons for that. One is anonymity. So if I'm in suite 101, I shouldn't be able to identify what suite 102 is doing. So this is a way to mask identity. As well, the theme of the building that year, per the Office of Residential Life, was games. So to be consistent with that, we just kind of went with the game theme. So students could select different time scales in which to view their suites or other suites' energy. They could look at energy by month, by day, by hour. And they can also change the units of energy and do some other things that I won't show here. Okay, so where do the field partners come in? There are several of them in this project, one being LA Department of Water and Power. And their primary objective in this was to be able to demonstrate a reduction in overall energy use in the building, as well as peak energy use. So in California, that's usually in the afternoons, and we have to think about that in the summertime when a lot of people are running their AC and we get peaks on the grid. That was kind of their primary interest in this sub-project. We also had our facilities management services at USC. They were the ones who installed the hardware and got the software systems up and running and talking to one another. And they were interested in getting this as a proof of concept so that other groups on campus could then use this building system in the future for other projects. And then we also had the Office of Residential Life that does programming for students in the dorms and runs like the Resident Advisors program. And their goal here was to have a fun event for their student or residents that fostered student cohesion for these incoming freshmen. So these were kind of all the goals that we needed to satisfy amongst our partners. So what did we want as researchers? We were working with the framework of self-determination theory. This is a broad framework that describes human motivation, and it posits that there are three main factors that support human motivation to engage in some behavior. First is autonomy, and that's the extent to which we feel like we can be causal agents in our own lives. Then there's competence, or the extent to which we believe we have the capacity to achieve something. And then finally, there's relatedness, how close we feel to members of a particular social group. Because this study was done in a group housing setting, we decided to focus on this relatedness variable in this project. And there's been plenty of cross-sectional support for self-determination theory, but not as much showing how these predictors of motivation might map onto behavior change. So we may know that relatedness fosters motivation at one point in time, but if we can move the needle on relatedness, does that translate to moving the needle on behavior? So that's what we aim to explore. So to kind of summarize our objectives and hypotheses across all of the different parties involved, first of all, we wanted to develop and test an intervention that leveraged this smart grid infrastructure to reduce both overall as well as peak electricity use. And that satisfied LADWP as well as facilities goals. Our hypotheses here were that we would see a reduction in overall use as well as peak use during the intervention period. We as researchers also wanted to look at the duration of changes in use, because a lot of research in this area tends to stop looking at outcomes right after the end of the intervention. So we don't really know what happens after you withdraw the intervention to see if changes persist. We wanted to look at this, and our hypothesis was that after the intervention ended, usage would reapproach baseline but remain lower. Next, we wanted to look at which particular behaviors would change in this intervention. And the hypothesis here was that electricity conserving behaviors would increase because the intervention we created was targeting electricity use, and that's how we engage students in the competition. We hypothesized that other pro-environmental behaviors would not change because those were not targets of the intervention. And then finally, we wanted to look at the role of group cohesion to understand processes of behavior change happening throughout this program. And one hypothesis here was that group cohesion would increase. This is what residential education wanted to see. And then if we think back to our self-determination theory framework, our hypothesis was that these increases in group cohesion would map onto more pro-environmental behavior. Okay, so what was our program? We called it Floor Tower Flex Your Power. This was a 3-week intervention where we gamified electricity conservation in this building. And the suites competed against one another to conserve energy in exchange for prizes. They received historical and normative feedback, which meant that they got information on how much energy they were using, as well as the suites in their building. And that was through both the kiosk as well as weekly flyers that we distributed to each suite individually. They also received information and tips on how to conserve based on equipment that we knew that they had in their suites, because remember, all the suites are identical in terms of major equipment. And we also prompted them to participate in peak savings events, because peak savings was one of our goals. And we also administered baseline and follow-up self-report surveys. So what were our results? For our first hypothesis, looking at reductions in overall use, we did see a significant 6.4% reduction, which is great. That's equivalent to about 3,700 miles driven by an average passenger vehicle. And additionally, we saw a 12.4% peak demand reduction, which is another excellent outcome. And I will also note that this occurred during a record heat wave in Southern California, where there were blackouts across Los Angeles. We were setting records for temperature as well as demand on the grid. There were no blackouts on campus, so that's not why these changes occurred, but it really does speak to the fact that the student participants really made a concerted effort to conserve during this period. Looking at our next hypothesis, what happens after the intervention? Do people continue to save? What we're seeing on this graph on the x-axis is the number of weeks after the intervention. And the y-axis is showing the percent change in electricity use relative to baseline. So what we want to do is stay in the green zone. That indicates that we're still conserving relative to the baseline, and the red zone is we're increasing. So we can see that 2 weeks after the intervention to 4 weeks, we're continuing to conserve. That's great. 6 weeks, we're kind of creeping back up towards the baseline, and then once we hit 7 weeks, we've gone back to baseline, and then we increase a little bit after that. And by the 10th week after the intervention, the students ended up a little bit over baseline in their consumption. So what does this tell us? This intervention was successful in achieving savings during the intervention, as well as for a short period of time afterwards. But after that, students rebounded back to basically what they were doing before. So we have to think about if this is a good long-term solution. Next, we wanted to look at types of behavior change. And remember, we administered surveys, and in those surveys, we assessed what students were actually doing. So it's great that we had the smart meter data to tell us kind of an aggregate how energy use is changing. But thinking again back to that pie chart that I showed when I first started talking about this project, we want to know what students are actually doing to achieve those energy changes. So we asked about this in the survey. And the blue bars here are showing baseline responses, and the orange bars are follow-up survey responses. And what we want to see are higher scores on the follow-up, which indicates that students are engaging in these energy conservation behaviors more frequently after the intervention. And that is indeed what we see across the board. The majority of these changes were significant, and the effect sizes ranged from kind of small for shutting off your computer when not in use to fairly large for encouraging others to save energy. So this is great. This supported our fourth hypothesis that students would engage in the electricity conservation behaviors. We also looked at non-electricity behaviors, things like conserving water, recycling, etc. And we did not see any significant changes in these behaviors during the course of the intervention, except somehow students reported littering less. I'm not sure what to really make of that finding still to this day. I'm glad that happened. But by and large, these non-energy behaviors that were not targeted by the intervention didn't change, which suggests that the suite of intervention tools that we used really did a good job at honing in on the energy behaviors. Now, next, we wanted to look at group cohesion. And we did assess this in the survey. From baseline to follow-up, this increased significantly by 4%, which is great. And that was a small, medium effect size. Additionally, we wanted to look at how this mapped onto behavior change. And we assessed pro-environmental behavior at baseline and follow-up through those behavior questions that we just looked at. And we saw that pro-environmental behavior also increased significantly with medium to large effect size. And when we look at the relationship between the increase in group cohesion, it does relate to an increase in pro-environmental behavior. So what this means is that over the course of this intervention, I'm feeling closer to those in my building, and that leads me, or is associated with, me performing more of these energy conservation behaviors. So it seems like what we had is by doing this competition and having this superordinate goal of conserve energy, this made students feel closer to one another, and that helped them work towards this common goal of conserving. So the takeaways from this project, first of all, some of our practical outcomes. We avoided about 3,500 pounds of carbon dioxide during the intervention with the electricity conservation results. And we got a 12.4% peak reduction as well, which again is really a big priority in Southern California for the grid stabilization. And that satisfied the goals of LA Department of Water and Power. The changes were relatively short term, so we want to keep that in mind. I'm an academic, so here I am caveating my results. However, I was approached by the USC Office of Sustainability the year after we did this study, and I met with them and kind of advised them on the approach that we had used in our project, and they took that and adapted it for a campus-wide dorm versus dorm energy conservation competition that they did for Earth Month the following year. So it's great to see that these results were used to scale up to a little bit of a larger concept. We were also able to show how the smart grid infrastructure that facilities had installed worked, and we were able to use it in this research project, so this satisfied facilities goals. And in terms of the student experience, we did see a significant increase in group cohesion, so this met the goals of USC Office of Residential Life. Finally, theoretically, we did observe increases in group cohesion, and these mapped onto increases in conservation behavior. So we were able to extend the literature on self-determination theory to behavior change. So that's kind of the summary of that project. I'm now going to shift gears, and I'm going to move on to another project that focuses on waste management. And the problem here is food waste. Almost all food waste is landfilled, and in fact, it's the single largest stream of municipal solid waste in the US. It's responsible for 11% of US methane emissions, and that's just from the decomposition in landfills. So that excludes any emissions that may be associated with transporting and managing waste. So likely the emissions are much higher. And in developed countries, households contribute almost half of food waste. So it seems like targeting food waste at the household level is a reasonable place to try and make a dent in this problem. And that is what we tried to do with our partners in the city of Costa Mesa, California. So this is in Orange County. It's south of Los Angeles, about 15 minutes from where I grew up. And we were working with the Costa Mesa Sanitary District. So City of Costa Mesa, it's a pretty high density place. It has a little bit higher education and income levels than the California state as well as US national averages. We were targeting 20,000 single family households that were served by Costa Mesa's Sanitary district in this particular program. And, excuse me, just like many cities across the country, Costa Mesa is scrambling to divert food waste from landfills through providing curbside collection systems, investing in new fleets of vehicles, and of course, processing facilities and staff. This all adds up to a very, very large capital investment. And Costa Mesa wanted to know, is this worth it? Especially when the success of all of this investment really hinges on household behavior change. Now, before this project, Costa Mesa residents only had one bin in which they discarded all their waste. So they didn't even have a recycling bin that they were separating into. Now, suddenly, through this project, we were providing them with a bin in which to throw their food waste. And so, if they didn't separate, then this was kind of not going to be very successful or a good use of resources for the city. So this current research is nested in a larger study that was done by Sally Geisler. And what was done in that larger study is a baseline survey was administered. The bins were then provided, the composting bin along with curbside collection service by the Sanitary district, and messaging what could go in each bin. And then there was a follow-up survey. So this larger project, the goal was to understand, does providing the bins and the service plus the information foster composting? Now, what our study looks at and what I'm going to talk about is whether composting leads to spillover behaviors. Because what we had here was an opportunity to look at maybe some hidden benefits of when cities or other folks in the field are making these large capital investments. Can this lead to more benefits than we might think to measure? So behavioral spillover is when the engagement in an initial target behavior is linked to some seemingly unrelated spillover behavior. And it's linked through what we call the spillover pathway. And this is kind of like a hidden social or psychological pathway that explains the association between the first and the second behaviors. And when it comes to pro-environmental behavioral spillover, it can be positive. So maybe you start recycling and you then start riding your bike more instead of commuting in a passenger vehicle. It can also work the other way, however, such as when you start biking and maybe you feel good about yourself because you're doing one good thing and you say, okay, I'm going to eat a lot of hamburgers now. Not good. So we really want to find opportunities where we can maximize positive spillover. And when we think about the theoretical framework for positive spillover, what's been found and has been most supported is this consistency hypothesis. And this stems from cognitive dissonance theory, which describes human tendency to want consistency in our thoughts, feelings, and behavior. So if I do one pro-environmental thing, I'm going to want to do another pro-environmental thing because I like to see myself as a consistent person. We also tie in self-perception theory here. And this describes that we infer our own attitudes and self-concepts by interpreting the meaning of our own behavior. So we look back on our past behavior as a signal of what sort of person we are. And so, for instance, if I look back and I say, oh, well, I'm a vegetarian, so I must be a pro-environmental person. Maybe next time I'm presented with an opportunity to engage in a pro-environmental behavior, I'm going to want to be consistent with my pro-environmental identity, so I'm going to do that next pro-environmental thing. The problem is that people have a lot going on. So we started to question, what do people focus on when they're looking back? So for instance, like in a normal day, you drink your coffee, you get dressed, and in a lot of our cases, we go and we lecture. So what do people focus on? Cognitive accessibility describes the frequency with which people interact or think about something. And we were thinking in this project that if something's more cognitively accessible, maybe people are more likely to see it in this looking back process. In the context of our project, people who begin composting are suddenly interacting with waste a whole lot more than they were before. Perhaps they have more thoughts about waste, and perhaps these thoughts about waste are more accessible or available. So our hypotheses for this project were, number one, focusing on whether spillover would occur, and we predicted that beginning to compost, the target behavior, would be associated with other waste prevention behaviors, water and energy waste prevention behaviors. These are the spillover behaviors. Secondly, we looked at how this process might occur, and we predicted that cognitive accessibility, or these thoughts about waste that we were predicting would be more available, would partially mediate the association between the target and the spillover. So the participants in the study had completed the baseline and the follow-up surveys in the larger project. They were not composting at time one, so we wanted only new composters. We wanted people who were adopting this new behavior, which is kind of a hard behavior, composting. And here is a description of our sample relative to Costa, Mesa, and US population. So you'll notice that our sample was a little bit more female and had fewer racial minorities. It also tended to have a higher education level than the comparison group. So we just kind of want to keep that in mind as we're interpreting the results. And again, because I'm an academic, I'm talking about limitations of my results. So testing our first hypothesis, that adoption of the target behavior would be associated with spillover behaviors, we first needed to know, did people begin composting? They did. About 71% of them adopted composting by the follow-up. So this is great. Looking at whether spillover occurs, that is shown in this graph. So the red bars are showing people who began composting. The gray bars are people who did not begin composting. And then we're seeing the spillover behaviors along the x-axis. So what this is showing is that those who began composting engaged in spillover behaviors at a significantly higher frequency than those who did not begin composting across the board. So this is great. This is evidence that spillover occurred, and that we can see that it occurred over a wide variety of other waste prevention behaviors. So people were unplugging devices not in use, not leaving lights on, that item was reverse coded, using less water, etc. So kind of a heterogeneous set of other waste prevention behaviors that they started engaging in, and this was tied to their decision to start composting. Secondly, we were looking at, okay, now that we know that spillover occurred, why did it occur? What explains the association between starting to compost and these other behaviors? And we looked at cognitive accessibility. So here is our mediation model, and I'll walk us through this. So first, what we're doing is we're testing for an association between the target behavior of starting to compost and the spillover behaviors. We just have unplugged devices here as a sample behavior, but you could switch that out for any of the other behaviors. And we see that there is a significant association here. We next look at the next step, which is people who started composting also had more thoughts about waste. Thoughts about waste were in fact more prevalent for those who began composting versus those who did not. And then finally, or the next step is that if you have more thoughts about waste, is this more related to the spillover behaviors? And it is. So much so that this initial association weakens in strength. And so we have cognitive accessibility explaining some of the association between the target and the spillover behaviors, and this shows that it is acting as a mediator. And we can see that this was the case across many of the different spillover behaviors that we looked at. Again, which is remarkable because of the sheer diversity of these types of behaviors. They're covering transportation, electricity use, water use, etc. And we found a consistent result. So the takeaways from this study, theoretically, we observed positive spillover. Those who began composting were more likely to engage in a whole other range of waste prevention behaviors than those who didn't begin composting. And interestingly, we focused on this difficult target behavior of composting, leading to relatively easier spillover behaviors. What's primarily been done in the literature is the opposite. So you try to get someone to do something a little easier in hopes that later you can ask them for a bigger challenge. But we showed that the opposite direction can also work. And We also demonstrated a new psychological pathway, cognitive accessibility, as an explanatory mechanism of the spillover process. So we kind of filled out this theory of consistency and how people look back on their previous behavior and what they're likely to see. Practically, we were able to inform the sanitary district's investment and show them that, yes, indeed, this was a worthwhile investment. And not only was it worthwhile for the initial target behavior of composting, but if we think a little bit more broadly and improve our understanding of behavioral responses to these sorts of policies and programs, we can understand ways to maximize program benefits, looking at different outcomes, and hopefully avoid unintended consequences. So we did not see negative spillover, and we would not want to see that, but cities might want to take that into consideration as they implement these sorts of programs. So going back to our initial questions about academics and field partners, can we work together successfully? Yes, we can. And what I'd like to emphasize here is that, like any relationship, if the social dynamics are good, there's a higher chance of a successful collaboration and a continued collaboration. And that being the case, you really need to think about and nurture these social processes. That means having ongoing two-way communication from the beginning. It means voicing your concerns, voicing your assumptions. I know that sometimes I've had collaborations or potential collaborations where there's assumptions that come up like, oh, they're the experts, they know what they're doing, so I don't question things that come up. But having these conversations that can be difficult sometimes can lead to better trust and a better collaboration experience. We also need to have appreciation for the other party's values. As I mentioned at the beginning, we have pretty different agendas. We're thinking about field practitioners and academics. And we recognize those and are open to kind of moving in the direction of our collaborators' values. This is going to help a collaboration as well. We need to have realistic expectations. I think this is particularly germane for early career investigators. We have the project management triple constraint. There is budget, timeline, and scope. And it can be very tempting to set very ambitious goals, especially as a junior person, without having the experience of what can actually be accomplished given your budget and your timeline. So kind of keeping that in check and having conversations about what can be expected is another recommendation that we have. And then, like any relationship, there's going to be setbacks, and you need to commit to working through those and to talking through those. So some final remarks. We don't suggest that all sustainability research necessarily needs to include academics and field partners, nor that all collaborations need to be truly integrative. Sometimes working in parallel is totally fine. Other times, you're missing out on a benefit if you're not truly working together. And so being able to recognize what situation you have is recommended. We do advocate for a system makeover to reevaluate institutional values. So for academics, this might mean thinking about promotion and tenure processes and what's incentivized. For practitioners, this might mean rethinking just the value of learning and knowledge and innovation, and not necessarily those like very measurable deliverables that tend to be a focus. But we need to find some common ground, I think, if we're to have more successful collaborations in the future. We also need to advocate for better communication patterns, more communication, and also different ways of evaluating impact. So not necessarily just, again, publications and funding, et cetera, but what sorts of practical impacts are you making in the real world? I'd like to thank my collaborators who have helped me with all this research and my sponsors. And I will now take any questions that people may have.
We have a question.
Right, thanks very much, Nicole. So Nicole will take any questions right now. You can put them on the Zoom webinar chat.
Or
You can go ahead.
I can talk, right?
Yeah.
Or raise your
I can
hand.
hear you.
This is Brian Shabbat, and I have this is more of a practical question about the usability of the findings you had in both of these studies. And
Okay.
in designing then a new intervention, how would you bring these together? And I have a particular interest in something we've been discussing here at Cornell, and that is how to reduce the carbon impact of business travel. And two interventions that we've discussed is one of them is using these webinar approaches more frequently. And the second one is having people pay for carbon offsets of the travel they undertake, which would increase the cost. So if we were to move forward with, let's say, both of these, how would we apply your findings?
I mean, I think that if you're asking people to travel less or to telecommute or to use some other way of meeting, if you will, that's like one target behavior. I guess I would kind of reframe your question or think from maybe a different level on like, how do we get people to travel less? Like that's the ultimate question. And there may be a range of different behaviors that you would want people to engage in, like these sort of webinars being one, carbon offsets kind of being one, although that's not actually changing the behavior. That's just
but you
offsetting it somehow. I would think about other potential behaviors that might be available that you would want to attack, and coming up with a program around any one of those. I mean, we could talk for hours about it.
Nicole, we have a question on the Q&A board here from Kimberly Anderson, which says, "Hi, thank you. Are you familiar with the community-based social marketing? If so, do you consider this research process worthwhile?"
Yes, very familiar. I teach it in my class. And yes, it is very worthwhile. It's a nice way to create a framework for designing and implementing a behavioral intervention, especially in the field with field partners.
And then following up on that, on a related note, how does ecological model work into your work? Ecological modeling. This is from Kimberly Anderson again.
Okay, I'm not really sure specifically what's meant by ecological modeling, but if we're thinking about assessing the impacts of behavior change, for instance, in the energy study, like the objective impacts of that was how much electricity was saved or avoided in that study. And so that's what I would look at for the environmental impacts. We have another study that we're working on right now where we're looking at the intersection of food, energy, and water footprints at the household level. And so for that study, we're gathering food consumption data as well as water and energy consumption data. And we are working with people in engineering here at OSU to estimate the ecological impacts of those direct resource use. So we're looking at the externalities of the energy that's needed to move water, the water that's needed in energy generation, et cetera. So it's not my area, but that's why we work in interdisciplinary teams.
All right, we have another question here, which is, I wonder whether these are just end of the pipe fixes to more inherent underlying problem that's called capitalism and such mindsets. Overall, other nations and concepts have resolved that for decades already, and so I wonder about efficiency of such efforts we saw presented, and why are not addressing them at the very core to be honest and intelligent about it? Why are we not addressing them at the very core to be honest and intelligent about it?
Well, I think behavioral interventions are one part.
So it's difficult.
What's that?
Sorry, I'm reading text very far away, so it's difficult for me to read these questions.
No, thank you. I got it. So I think behavioral interventions are one part of, a sustainable future, but it's one part, and we certainly need to attack things from other angles like policy, et cetera. In terms of the commenter's point about mindsets, that's exactly the type of work that we do in my lab, is to try and understand how people are making these decisions, what factors go into their decision making, what predicts these behaviors, and then how can we target those motivators in order to get people to choose more sustainable behaviors. You have to start on a small scale and then scale it up. So that's what I would say to that.
I have a question for you, Nicole. The work that you do you integrate decision-making processes with the partners and or stakeholders to evaluate different alternative management strategies or different implementations in a kind of decision analysis framework?
You mean, do we talk about like our theoretical hypotheses with them?
How do you work with decision makers, for example, to evaluate trade-offs of making different types of interventions? So what would be a more successful intervention given specific behavioral changes that you might predict?
Yeah, for sure. And oftentimes when working with field partners, because they tend to be responsible for implementing the programs, they have to be on board with what solution gets picked. So I find myself in kind of an advocacy or like, I don't know, role of like playing a guide of like, okay, here's what we know from the research. Because what I've often found is that field practitioners will get really excited about an idea that they've heard from X, Y, or Z other place. And they'll be like, we want to do that. But without also considering what the scientific research is and what the theory is behind that, we're kind of missing part of the story. So I try to bring that and talk about it also in the context of what they want to do and what the constraints are of working on the ground.
Okay. We have another question here from Vanessa Springer at Cornell. She's asking, have you done work in lower income communities? And if so, can you talk about how interventions and outcomes might differ?
I have not specifically targeted low-income communities, although for the food, energy, water study, one of our target subpopulations is a low-income community. So we will be doing that. So unfortunately, I can't speak to that yet.
Are there other questions out there, either via the question and answer or live? Okay, so I think that's the end of the question and answer. Thank you for the discussion, and thanks very much, Nicole, for your presentation. I'd like to note that we're in the process of developing the Spring 2018 Computational Sustainability Virtual Seminar Series, and so if anyone has any recommendations of future speakers, we'd be happy to hear those. So please send us a note with your recommendations, and we'll be finalizing the schedule for next spring semester here very shortly. And you can find that update on the CompSys.net website. And so thanks again, Nicole, and that concludes this webinar.
Thank you, Angela.